when you try to crystallize these proteins in a Earth gravity environment, these crystals reach a certain size, after which they tend to settle to the bottom of the beaker because of their size and mass. This problem is not there in microgravity environment. You can crystallize much larger crystals which don't necessarily settle to the bottom of the beaker that they are in, and this gives benefits in terms of drug discovery because you can take this larger crystallized proteins, bring it back to Earth for further analysis, and these larger protein crystals benefit you from both a drug discovery standpoint and also to see where you can attack. Let's say you take a cancer protein to space and then you crystallize it, and then you can see, you can look at the targets better. That is something that you won't be able to do in a earth gravity crystallized crystals. And then you also have, in the same pharmaceutical side of things, you have 3D bioprinting. What happens is, in an earth gravity environment, you need to have a complex support structure when you're 3D bioprinting something. So after your bioprinting of that tissue or that organ is done, it's very difficult to remove that support structure or that scaffolding to get what you, the primary object that you printed, 3D bioprinted. But when you go to a microgravity environment of space, that same complex support structure is not needed when you try to 3D bioprint something. So you're able to print these very thin single-celled tissues or organs with great precision without the need of a support structure. So on the other end, you also have the material science side of things, in the sense the International Space Station, they have it has something called a high temperature furnace where you can do semiconductor crystal growth experiments. So why do semiconductor crystal growth experiments into space is because you can grow much larger, much more purer semiconductor crystals as compared to what you can do back here on Earth. One challenge of the International Space Station is NASA has very stringent safety standards in place because astronaut lives are involved. So even though this furnace was installed in the space station back in 2011, it was never used for the purpose for which it was intended for, because the experiments never passed those safety tests on the ground before they could be flown to the International Space Station. So that's where we want to come in and say unmanned platforms like us don't have as much stringent safety standards. So we want to be enable those type of semiconductor experiments to be done in space and be brought back.